All right, today we're going to look at a couple of the questions from our lesson 10, 1B, where we were doing the axis of symmetry and the x-intercepts, but now we have some questions that are asking us to look back to what we did previously in 10.1a, where we were thinking about the vertices, the axis of symmetry, domain, and range. So in this question, we're asked, what is the domain and range of any parabola with a vertex of 1, 0 that opens downward? Now, remember our vertex. That's the point that's either the highest or the lowest. Since it opens downward, that means that our parabola looks, whoa, that looked kind of bad, looks like this. And it's opening downward. And we know that this point right here, I'll use a different color though, I'll use the rainbow. This point is 1, 0. So what does that mean about our domain and our range? Well, see how we have arrows down here and down here? That means that it goes on forever and ever and ever. And as you can see, it's slightly moving to the left here and the right here. It'll keep moving to the left and right forever. The domain of a parabola is always going to be negative infinity and positive infinity. Every single time. No matter if it's facing down or up, because it'll always go to the left and right forever. What we're now looking for is the range. And in the range, we have to decide, where is it going on forever, down or up? Well, if we look, we're going forever down. That means we're going to start with negative infinity. Then the highest point we can go is right here, right at point 1, 0. And since this is the range, we're looking at the y value. So we're going to put a y value of 0, and we're going to enclose it in a square bracket, because the square bracket means that we are trapping the number, we are including the number with our answer. So all of your problems that are like this are going to have a negative infinity, positive infinity for the domain, and for the range, it's going to have the negative infinity or the positive infinity, and then the number in the bracket. Now, looking at the second type of problem, if a quadratic function has a vertex at negative 3, 4, and x-intercepts at 4 and negative 2, what does the y value of the vertex represent? Now, what we're thinking of here is we're trying to envision what this parabola is going to look like. So, if we are thinking about a graph, like a coordinate graph, I'm going to draw mine kind of sloppy, but that's because we're just trying to visualize what this looks like. It says our vertex is at negative 3, positive 4. So if here's 0, here we go, 1, 2, 3, and positive 4, our vertex is going to be right about here. I'm going to put that this is the vertex. Oops, still getting used to this program. Okay, that's our vertex. Then it says we have x-intercepts at negative 4 and negative 2. Okay, so I just put something for negative 4 and negative 2. That means that our parabola is going to look like this. Super cool. It's facing down. The question is asking, what does the y value of the vertex represent? Now, let's look back at what we did over here. The y value of our vertex, this 0, told us this part of the range, right? It told us that we're going to go from negative infinity and we're going to stop at 0. If you remember from last time, we had a name for what happens if it's the highest point. We called that a maximum. So if we're looking over here, this 4 this 4 right here, this 4, it's the highest point that the parabola is going to go before it starts going back down. That makes it a maximum as well. Now, it doesn't ask you about the x-coordinate, the -3, but if it did, the x-coordinate is always going to be talking about the axis of symmetry. The x-coordinate is the thing that cuts the parabola exactly in half so it has 2 symmetrical sides. That's the x-coordinate, whereas the y-coordinate is going to be the maximum or the minimum. The vertex is important because it tells you all of those things. It tells you the maximum or the minimum. It tells you the axis of symmetry.